Hi, welcome to Wiring Wednesdays. I'm Ben, I'm the production manager here at Syvecs, and today I'm going to be talking about different crimping methods, how you should be doing it, how you shouldn't be doing it, also some different types of splicing and what you should be doing when it comes to that. So I'm going to introduce each of these crimpers. These are a handful of what we use here at Syvecs when we're producing looms, engine looms, Lamborghini looms, anything like that. They're pretty much used throughout our entire range of products. So we have what is quite well known in the industry, which is the Deutsch crimper, as we call it here. This particular one is brilliant. The only thing is, like every tool, it has its plus and its minuses, or positive and negatives. The crimping force on this particular crimper is brilliant. It's quite easy to use. It has a range of pins that you can work with, but it also has its limiting factors, which is speed, unfortunately. So this particular one can take a little while to work with. It also takes a little while to get used to. If you go beyond the pin types that this particular crimping tool is catered for, then you're having to buy new tooling to account for it. So it's quite a simple tool. It has a ratchet release mechanism inside of it. So I'm not sure if you can see that there. So once you pull the handle down, as you can see, I'm just doing with my thumb and fingers here. It's quite easy. You can see the 4 points come in, which will crimp the wire. And in a moment, I will demonstrate how you should and shouldn't be using this particular tool, along with the others. Next up, we have the Racetronix crimper. This has the Amp Superseal die set inside of it. We only really use it for these, but we have found some pin types that we can use with it as well, and they crimp perfectly well. So I will be running a demonstration of this, and there's two particular pins that we use with this die set. Fortunately, it doesn't work well with others, and there is a downside with this particular crimper. As robust as and well built as it is, the die sets can be quite costly, and using them as a hobbyist is not exactly ideal. Next, we have the Knipex 975233s. A lot of people may be familiar with these crimpers. They're not actually for pins, but they are for butt connectors, which again, I'm going to demonstrate in a moment with some wires. They're great for splicing. Their mechanical contact is exceptional. You're more likely to break the wire than you are the crimp. So in a moment, again, I will be showing you those. Next up, we have the Racetronix 199T10. Now, in my opinion, this happens to be, along with its brother, which is the blue set, is one of the most diverse crimpers around. And I know there are a number of people out here that agree with me on this one. For bang for buck, these are the best crimpers that we have used in Syvecs, and a number of friends have used in the industry. So just want to point out that we do actually supply these to our customers, and if you need some, because I know they are quite difficult to get hold of because they're from the States, please let us know and we can supply you with those. So I'm going to start with the Deutsch crimpers, and I'm going to indicate to you how this should be done. I mean, this is pretty self-explanatory. Most people that pick these up know how to do it first time. That's the beauty of them, and I mean, that's probably what makes them so expensive, is just how easy they are to work with and just how hard it is to get it wrong. But there are a couple of ways, so I'm going to point that out now. So when you're working with this particular set of crimpers, there is a depth, what you want to say, where it bottoms out to, and you can adjust that by turning the locking nut here, and the height is adjustable based off of the bolt at the bottom. So it's important that you should be doing this whilst they're open, namely because once it's collapsed, you'll see that this in here will actually make contact with the actual die inside, and you could end up damaging it somehow. So we don't want to be doing that. So we're going to take a female Deutsch pin here. We're just going to pop that in. And inside of here, the best way to be doing this is that if you run your finger over just this point here, and you can feel the pin itself protruding, you're too high. So what you need to be doing is dropping that down. So I'm going to drop that down here, and then that should be about right there. And we're just going to run a little test crimp. Okay, so as you can see, the pin itself is just underneath this edge here, And what we're going to be doing is we're just going to crimp this pin. And now you can see how that's collapsed inside the pin there. So we take that out and we're just going to do a quick inspection on the first pin. And what you're aiming to do is you're aiming to get the crimp on the pin almost immediately in the middle of this top section of the Deutsch pin itself. So we're pretty close, it's not far off. As a rule of thumb, you kind of want it around there. So next thing we're going to do is we're going to check the gauge that is on the tool to make sure it's correct. As you can see, that the gauge is set to 0.5 of a mil or 20 AWG or 20 gauge, and that's perfect with the wire that we're working with now. But if you did want to adjust this, all you need to do is lift that up. There's normally a locking pin in here. We take them out because we adjust them quite a lot in here, so there's no point in having it in. So we can rotate that down to 0.75 mil or 18 gauge or 16 gauge respectively. Any higher than that, then you're sort of starting to move into the realms of needing another tool. But this is pretty much what we use it for, is 20 and 18 gauge or the occasional 16 gauge. So I'm going to crimp this now. Just make sure that's on 20. Make sure it's level, which it is. I mean, once you set these things, they're normally pretty, you're not really setting them again. If you're using the same pins over and over again, generally once they're set, but it is good practice to make sure that you are using the tool correctly anyway. So now that we've got that in there, we're going to let that bottom out. I have set the machine to 4mm to strip that, and it's stripped it for me, so it's nice and clean. Make sure you don't unravel the core of the wire, because it will make your life difficult if you're trying to get this in here, and I'll show you in a moment what it does if you do. So if you get that in there like that, all you're doing now is squeezing, let go. Now you can see the pin is perfectly in place. There is one final note, a viewing hole, which I'm not sure if the camera's going to be able to pick this up, at the base of where this is crimped. And you can actually see, if you want to be really, really certain that it's gone all the way down, you want to look inside that hole, you'll be able to see that the wire has made contact with the base of the pin in there. Okay, so this is what happens when you don't do it right. So I'm going to unravel this, make a mess of it, and you know, this is where it's good practice to handle your wire properly. I'm going to pop this in here, and what happens if that is now, as you can see here, is now a little bit messy. So I'm going to try and put that in here, and as you say, when you're in a rush and you're trying to do this quickly, this is not ideal. So you're going to be, you know, okay, I can already feel resistance there, but that's my experience telling me that. And I'm going to pull that away, and now you're going to see things like, you're going to see wires start protruding from the outside. And I mean, I got away with that one, but that's what you're looking for, is that the wire has jumped out. It's now sat around the top of the pin. In a worst case scenario, you can have up to, you know, north of 4 or 5 wires in here, which in turn reduces the tolerance of your cable or wire. One quick point, and I have seen people do this, is take larger gauge wire and attempt to get it into a 20 gauge pin. It's not a good idea. This particular pin is rated to a certain level, and you should be aiming to find a pin size. So this is a DTM. You want to be finding a pin such as a DT if you're looking to go to, say, for instance, 18 or 16 gauge, but generally this is perfect for sort of 22 to 20 gauge. Right, now that's the Deutsch range out of the way, at least briefly. So I'm going to move them out of the way now, and I'm going to bring in our DI pins, and which are the AMP range. So we've got the Superseal pins, which everyone should be very familiar with, having worked with various products, including our own. These are also part of the AMP range. We call them a DI pin because that's pretty much the only kit that we use it on. These work well also with the Racetronix, which the die size happens to be great. It works the same. They are a very robust pin. They can take quite a lot of current. This just so happens to be one of the few things that this particular set cannot crimp properly anyway. So I'm going to show you how to crimp these properly, as well as the Superseal AMP pins. The Superseal is pretty straightforward. This is actually a die set for them. Generally, I don't like to use the 20 gauge die. For whatever reason, it can cause it to bow. So I'm just going to pop that in there. I'm not going to waste the wire because it's used for demonstration purposes, but you'll be able to see what I mean. So when I crimp this, as you can see, it's sort of gone off at an angle. So as you can see, it has bowed the pin, which means it's overpressurizing the pin, which is not ideal. There's a couple of ways to actually see how this has happened, and it can be the design of the die, it can be that the crimp is too aggressive. There's a number of factors that are involved, and we also have machinery here that we have to calibrate to suit such a scenario. So if you look just here, there is an edge on the base of that crimp, which normally means it's over crimped, and it starts to break the actual body of the pin. Now, if I crimp this into here, it's going to create even more pressure, and it will bow it even more. So I'm going to put this in here again. Oh, if I'm going to pick that up, I'll pop that in there. Now, you should be able to see this bow when I crimp. That is not what we're looking for. And as you can see at the back on this edge, it is now protruding even more, which means there's far too much pressure involved, and this will result in the pin snapping on this edge. So generally we can straighten these out, but with a little bit of force, it ends up breaking, which is not ideal. So we're not aiming to do that. So for some reason, the 20 gauge die is not what we're looking to use. This comes down to preparation. So you're looking to use particular pins. You want to make sure that they're working right with the material you're using. I'm now going to pop this in the 18 gauge slot. Now I'm going to pop this in here, and as you can see on the front edge here, the pin itself is aligned with the die, and it's slightly inset just here. Now we'll pop the wire in, and what we're aiming to do is get the wire not all the way down. You don't want to be forcing it all the way down past the die. You want it on the edge of the die as well. So now if I crimp this, it should just stay in there. There shouldn't be any force bringing this out. Now we're kind of in it's a bit of a weird one. So with this particular one, as it was before, so I'll just bring that one back in. You can see on this top section, this has actually grabbed or started to grab on the insulation. Now there are two things here. This particular wire has a very, very thin insulation. Most people don't generally use that, and I believe that this particular die set is designed to work with a larger insulation, therefore it's not grabbing here, and that's why that's a 20 gauge. But if the insulation was slightly thicker, you'd be able to get that grabbing. Now this is why I don't always use the Racetronix for Superseals. We have a machine that does this, but in the field it is handy to have them. Now as you can see, we've gone up from the 20 gauge to the 18 gauge, and now the die is only suited for an 18 gauge insulation. That's not great either. So generally when it gets to this point, I'll use the T10s, and I'll go back in here, and I'll either, depending on what I'm doing, I'll either use a pinch die to just make that a bit tighter so it's holding on to it, or you could alternatively use the B, which is, you know, the rounded die, to round that off and make it a bit tighter as well, as you can see there. Now this is what we've been using the Racetronix for, namely in-house, and these are the DI pins which are used for most of the DI kits, or the Syvecs kits. So we're going to pop this in here, and I always put this on the 16 gauge because these are really heavy duty pins for what they are. So get a couple of clicks in, and generally we do use 16 and 18 gauge on these. It's not a good example with this, but it's the principle still applies. So now this particular pin is slightly different. You're going to notice that one of the barbs on the rear is now aligned with the die at the back, and that's important. And also at the front, if I rotate them, you can see the die is also in line with the pin here as well. So it's important. The main one you need to be, number one, is focusing that the die is in line with the pin at the front, which is this side. And then on the rear is secondary. So you just need to be making sure that this is either aligned or not falling out, or whether you're going to have to do the crimp twice to get both parts of the pin. Some of them you do. So I'm just going to get a wire here and feed that in. Again, in line with the face of the die. Crimp down. These ones, due to the nature of these particular pins, is that they tend to bow again, but it's not as severe, but they're a lot stronger, so you can manipulate them a little bit as they come out. I mean, if they bend at 45 degrees, then that is a problem and you're doing it wrong. But if they have a slight bow on them, like this one does, that's fine, but you can just manipulate that slightly with your thumb and finger, just to make sure that it seats in the connector properly, like so. Now I will note that this particular die set doesn't crimp the forwardmost part of the pin entirely, but it does most of the job, and you are going to struggle finding a particular tool for these pins without spending an absolute fortune. And as it stands, that this is the best solution that we have, that we can give our customers and say this is probably bang for buck, the best way of doing this without, you know, really hurting your wrists on this one, because these are really strong pins, or they're just so thick. That's the problem. The actual tool for this, from memory, is about £1,500 if you're looking to buy the proper tool that's been designed for that pin. Next up, we have the Racetronix T10s. As an all-rounder, these are fantastic. We would recommend these to any of our customers if you're looking to do any wiring on your car that obviously doesn't involve Deutsch pins in the barrel type. I have personally built full engine looms with this particular crimping tool. The range that they're capable of is nuts, and the sister of these, the blue handles, and I can't remember the number of them for the life of me, but we'll pop a comment down below if you'd like to know, is fantastic. So I'm just going to run a couple of examples here. So this is the pin that we use for the S12 kit. This is quite a delicate pin. It's not one that you can just put into a ratchet crimper. Generally these need to be hand done and double crimped. So as you'll see, I'll show you now. This is on the back section here, which will be for a 20 gauge. So I start with the barbs at the back for grabbing the insulation. Not sure you can see that, but the crimper is actually quite, the width of the crimper starts to grab on the contact part for the wire. That's not a problem. We can get around to that with a second crimp. That's the whole point of crimping twice with this one. So take that off. To pop that in. So you're aiming to get the wire again at the front with the barbs either side and flush, and then what you're going to do after the first crimp, as you can see there, it's sort of bowed it, but that's not a problem, we're going to get to that and it will fix it, is that you get to the front one and then crimp again, so you have a double crimp. Now that's done. That's how we do our S12 kits. You're not going to pull that out of there. That's strong. The only real downside to these is that they aren't ratcheted. You are using full force of your hands, and it does take a bit of practice. Like one of our apprentices, took him a little while to get used to how much force you need to really put into these. And we often say, if you put the base of this crimping tool on the table, like so, and then just put your torso weight on top of it, and you're not going to have any problems. So that's pretty much it. But that's the only real downside to these crimpers. Other than that, they cover our S12 pins, all of the timer pins, which is the micro timer, mini timer, and junior timer. They cover the JAE pins. I mean, they also cover the Superseal pins as well. And arguably, I'd rather use this in the field for crimping the Amp Superseals than the Racetronix. Last but not least, we have the Knipex 975233s. These are barrel crimps. So as you can see here, if you're looking to make a splice or join a wire together, these are the ones that you're looking for. So I know there are others out there. These aren't exactly cheap. Off the top of my head, I can't recall, but we can find out for you if you'd really like to know. They are brilliant. They're not linear crimpers. They're sort of your standard style crimpers. They generally end up, you know, creating a massive amount of force on a splice or a barrel crimp such as this. We've got different gauge sizes for in-house use. We don't solder any joins anymore at all. It's all barrel crimp. So this particular one, which is the part number, which I've got on the tray here, 8092363. You can get those from RS Online when they're in stock again. And you can get two 20 gauge wires in here. So I'm just going to strip one of these off. Make sure they're level. I'm going to pop that in there. There's a little bit of squeeze, but if you get these, if you treat the wire properly and it hasn't blown out everywhere and it's still twisted up nicely, it will actually, the wire will go in there and you'll pair them up. You'll find that you'll need to strip the wire a little longer than you would if you're putting it on a pin, normally about 1 mil. You could go as far as bottoming it out on, there's actually a butt inside that stops the wire going all the way through. But this is sufficient enough. So you just a bit of a squeeze there. As you can see, that's now nicely crimped. That is not coming out. You're more likely to break the wire than you are to rip that out of there. We also do 3-wire splices. Generally, we'll use the larger gauge size and we'll step it up a notch. But that's pretty much it. If you've liked this video, please consider liking, subscribing, and leaving a comment. If you have any questions in regards to what I've been talking about today, please let us know either at support@syvecs.com or in the comments below, where we will endeavour to look at what you said and we'll get back to you as soon as possible.